So basically, OSPF. So OSPF is a widely used network protocol, right? That is called a that is a widely used routing protocol. Okay. So
Okay.
OSPF. Just let me share. Okay. So OSPF is a widely used what? Widely used routing protocol, right? Routing protocol. Well, there are lots of protocols also like routing information protocol and EIGRP, IS and so on, right? But what is the reason to consider the OSPF? Because if I talk about the OSPF, so this is the protocol that we are using in the real time for the local area network within the local area network. We also call this we also call this the IGP protocol. Which one? The OSPF is an IGP protocol and and it works within single AS, right or not? Within
Yes.
single AS, yeah. Within the same AS, we can say same AS, same autonomous system, right? So let's talk about the OSPF. So OSPF is far better than other protocol, right? But you will say, no, sir, we have an AD value for the EIGRP 90, but OSPF is 110. So why we are using the OSPF over here? So the reason, first of all, is that this is a Cisco property, right or not? So this can only
Uh,
be used within the Cisco devices, right?
yes.
Clear? Yeah.
Yeah.
And we have some better options like partial update. What? So what is the meaning of partial update here? We have an option for partial update forwarding. What is the meaning of that? The meaning of that is forward, forward necessary updates. What? Necessary updates to the neighbor router, right? So if we have this option to forward the neighbor, to forward the partial update to the neighbor, so this is somehow a better reason to consider as compared to the other protocol, right? So
Okay.
as we already have seen, there are lots of calculations and the data forwarding we have done even in our last class about the EIGRP, right or not? And what we have seen that the EIGRP forwards the updates, right? Forwards the updates to the neighbor. But in that update, what were the details included? Is it also forward a partial update? No, it will not forward the partial update, right? In case of update, it will forward the entire database. But we have an option in OSPF. What is that option? That will be automatically forward. That is called database description. Later on, we are going to discuss about this also. Okay. So
Okay.
this is how this protocol is somehow special as compared to others, right? Now, you can say, sir, what is the reason to consider the OSPF within within the local area network? Why can't we use on wide area network? Except of AD value, there can be any other factor to consider, right or not? This protocol can also be used in what? Wide area network. But what is the reason to consider the OSPF within a local area network? Can you tell me?
It is a shorter administrative distance.
Yeah. Except of this one, can there be another reason to consider this for the local area network only, not the wide area network? This question can be asked in your interviews also, or
Maybe
in real
is
time
it the
also
hop
you
count?
can. What dear?
Is it the hop count? It has a high top
Yeah,
count than
yeah,
others.
yes, yes. Because if I talk about the EIGRP protocol, that can also be used in what local area network, but it can be limited to 100 hop count or 100 hop count, right or not? But OSPF has unlimited hop count, clear, but it is but still it is limited. Why? Because the reason is that it can only hold up to a data of thousand what? It can only the hold the updates or hold the database up to 1,000 routes, right? Clear? But
Yeah.
there's a protocol called BGP that can handle handle 100,000 of routes. What? 100,000s of route easily. But if this protocol, if I will if I will provide the data of 100,000 route to the OSPF, it will not work. Okay. So because of this limitation, we are using the BGP over here for the wide area network, right? That is why this protocol is not working over there. And it is limited to what? A local area network only. And in that case also, we are using the area concept. What? Area concept in OSPF to reduce the load, right? To reduce load basically. What type of load? So there is something called database table in OSPF. What? Database table. To reduce the database table, we are dividing the network into areas also. Now you will say, sir, it's really hard to understand what you are talking about. Okay. So let's start with the basic of OSPF. Okay. So this is just an overview. Okay. So OSPF is a widely used routing protocol, right? And it is a link state routing protocol. So can anyone tell me what is the meaning of link state?
Um, I used the state of a port if it's up or down.
Yeah, state of ports, links, right or not? So that is why this is called link state, right or not?
Right.
Clear? So
Yes.
what is the meaning of this port state and so on? So there are lots of factors. What are these? These factors are there.
Yeah.
If I talk about nodes, what nodes, right? There can be lots of nodes in our network. Clear? So the lots of nodes combined to construct a network. Clear? Lots of nodes like router 1, router 2, router 3, and so on. So lots of router are connected to each other by and that creates a network, right or not? And in case of OSPF, in a same area, you must have the information of all of them, how they are connected, and which are the link, which links are connected to them, which is the best route, right or not? What is the route metric for all of them. So these details must be there, right? And this is why this is called a link state protocol, right? It provides the information directly to all routers in same AS network. OSPF sends information about directly connected links to all the router in same AS number. That is means if this router is connected firstly and there is a router that is connected after 20 nodes, so that router must have the information of all the routes connected in the nodes. That is why it is called link state. Clear? Clear about this?
Yeah.
Yeah. Okay. Now, this protocol uses the Dijkstrol algorithm, right, to find the best path. So why need the best path? To construct the routing table, right? The routing table will be constructed on the behalf of best path and best path will be selected on the behalf of shortest path first algorithm or Dijkstra's algorithm, right? The protocol number of this protocol is 89. Clear. And it is a classless routing protocol. What is the meaning of classless routing protocol? That it can support the subnets. Like we can use the subnet slash 29 slash 27 slash 25 slash 23 and so on. All the subnets will be supported by this protocol. And it also supports the authentication. Clear. Authentication we will cover up separately for all of these protocols, like how the authentication will be done in routing information protocol, EIGRP and OSPF with the comparison also. Okay, we are covering separate about that. It supports both IP version 4 and IP version 6. Okay, now let's talk about the AD value. What are the AD value over here? Intra area. Inter area is 110. Inter area is what? 110. Intra area 110. And external is 110. What is the meaning of inter and intra area? Inter area.
I think
Intra area,
inter.
it's
Yeah.
Yes. Yes, dear.
okay. I think intra area it's within the same area. Then
Yeah,
inter area
within.
it's within different areas.
Yeah. This is within same area, right? And inter area is different areas. Okay. So this is for the same area and this is for the different area, right? Dear, to forward the data in between the different areas, we use the LSA type 3. Later on, we are going to deeply discuss about this also. If I talk about, sorry, for the inter areas, for the different areas, we use the LSA type 3. And for the intra area, for the same area, we use the LSA 1 and LSA 2. Okay. So later on, we are going to deeply discuss about this with the packet flow. Okay. Let's talk about the external. For the external areas, there will be link state advertisement 4 and 5. Okay. Now let's talk about the timers in OSPF. So we have hello timer that takes 10 seconds to repeat, right or not, to forward a hello packet to the neighbor. But we have seen in EIGRP what was the time to forward a hello packet? What was the hello timer? Can anyone tell me?
3 seconds.
5 seconds, right? And we have here that timer. Okay, that timer is of 40 seconds. If any route will be unreachable after 40 seconds, that route will be automatically deleted from our tables. Okay, in case of AIGRP, we have hold on timer also. Hold on time is a waiting time for the neighbor update and that takes approx 15 seconds to be repeated, right? This is for the IGP. Okay. Let's talk about the multicast addresses. So hello message has a multicast address of 224.0.0.5 and this is update packet multicast address. Okay. So dear, I have a question for you. In which case the routers will multicast the packet and where router will do the multicast and in which cases it will do the unicast. I think in last class we already
Of the
have
IP,
discussed,
probably.
yeah, when we have the point to point link with serial, in that case it will do the unicast, sorry. Okay, in case of, and in case of point to point with Ethernet, In case of Ethernet links, it will do the multicast, right? If there will be gigabit Ethernet connected, okay, or fast Ethernet. So in that case, is the routers will do the multicast in forwarding the messages like update, query, okay, reply. So these will also be in case of EIGRP we have seen, right or not? The multicasting was done.
Yes.
In OSPF also there is somehow the multicasting will be done. Okay, we will talk about this later. Okay. So any confusion with the multicast? Is anyone here in the class who don't know what is the meaning of multicast? All of you are aware about the multicast? What is the meaning of multicast?
Yeah.
All of
Yes.
you aware about this?
Yes.
Okay, okay, that's perfect. We can move forward. Okay. Now, there are some routing codes of OSPF like single area, right? Other area, inter area, this is intra area. Okay. These are the routing codes for external. Okay. And now a topic is there router roles. Designated router, backup is designated router and DR other, right? So dear, it can be happen in case of OSPF that router 1 and router 2 and router 3 they are connected with the Ethernet link, but there can be any other devices connected in between them, right? Already they are connected with the fast Ethernet or gigabit fast Ethernet, okay? Fast Ethernet and a switch, a layer 2 device can be connected in between them, okay? In this type of scenario, in these type of scenarios, LSA flooding can be done. What? LSA flooding. To stop the LSA flooding, we decide the roles of the OSPF routers. These are the designated router, right? Backup designated router and DR other. Okay, we have a separate session for this also. Okay, and in that the election will also be done. We will do this practically. Okay. Now, what is the meaning of process ID? Right? The process ID is only used to the initiate the OSPF instance. Okay, in between the different routers or on the same router, but it differentiate the multiple OSPF instances, right? This process ID is used to initiate the OSPF process basically, and also differentiate the OSPF instance. So in case of EIGRP, when we were doing the configuration like router, EIGRP, and then we provide the AS number here, right or not? But in case of OSPF, right, like router, OSPF, during the configuration, we provide the we provide the process ID. What? Process ID. And the range of this process ID can be in between the 1 to 65536 somehow. Okay. Like in this example, we have provided the router OSPF 100. So this is the process ID. Okay. If the two routers are connected, this is router number 1. Okay. This is router number 2. If they are connected in the same area, okay, they can easily create the neighborship. But if they have different bandwidth, the neighborship cannot be formed. Okay. And secondary, if they are having the different process ID, then they also cannot the OSPF instance, right or not? They cannot run the OSPF process over here. Clear? Now the question is that what is router ID? So router ID is basically you can say that a name of router on the behalf of that, on the behalf of that, yeah. Routers will share the data and also will create the tables. Clear? It just look like an IP version 4 address and its size is 32-bit. Okay. Every device of every device router should have a unique router ID. It has to create the database table. Clear? We have the three options to provide the router ID. First of all, we can manually assign that. Secondary, the router will automatically assign the router ID on the basis of election processor. So there are two processor for the election. First one, first rule says if the router having loopback addresses, so the loopback which is having the highest value will become the will become the router ID. Secondary, if loopback is not available, then the highest physical interface IP will become the router ID. Okay, let's clear this with an example. Okay, so here we have example for the same. Okay, so let's start with router number one. So router number one has a single IP address 200.0.0.1. It will automatically be assigned as its router ID. Okay, because single candidate is here, there can be no competition, so this will become the router ID. Okay, no election will be done. Let's talk about router number two. It is having the four IP addresses, right? In these four IP, two IP are the loopback. So if any loopback IP is available, so loopback must be considered first. And in that loopback addresses, the highest loopback IP address will become the router ID. So this will automatically become the router ID. So for this router ID will be 10.10.10.10. Clear? Now let's talk about this router. It is having two IP address 210.0.0.2, 100.0.0.1. Two IP addresses are available. The highest IP address for the physical interface. There are two physical interface, two IP addresses. Highest physical interface IP will be automatically become the router ID. Clear? And this selection will be done by the router itself after running the OSPF process. And if I talk about the last router, single IP address is available. So this will be automatically assigned as the router ID. Let me give you some questions. Okay. And let me know which one is the router ID for a router. Okay. If there are some routers connected like this is router number one. Okay. Router number two, this is router number three, this is router number four, this is router number five. Okay, they are connected just like this. Okay, clear. It is having two loopback IP addresses like 201.0.0.1, 202.0.0.2/24/24. Okay, and the physical interface IP is 192.168.0.1. Let's take an example. Okay. On this side, we have 192.168.0.2. Okay. Here we have 192.168.1.1. Okay. 192.168.1.2. Okay. Here we have 10.0.1.1, 10.0.1.2. Okay. This side we have 11.0.1.1, 11.0.2.2, 1.2. Okay. So for router one, which will be the router ID?
Why what 92.168
Uh-huh.
dot 0 dot 1?
No, dear. We have two loopback interfaces also.
But
First of all,
if the loopback
yeah.
are not if the loopback are not enabling OSPF
Yeah.
process, we'll use this
Yes,
as
dear. Yes,
at the
dear. If the
beginning.
loopback is
You
not
should
done.
specify.
I told you that there are two loopback IP addresses. So this will become sorry, this one 202.0.0.2. This will be the router ID. Okay. So the router ID is 202.0.0.2. Okay. For
Does
in
that
if I
mean,
talk, yes, dear.
sorry, does that mean that a loopback address doesn't have to have the notation /32? It can have any notation.
Yeah, you can have any notification, don't worry. This
Okay.
will also can be assigned as the loopback /24/16, whatever. Okay. Now let's talk about these in between R2. For R2, which one will be the because all of these are interface IPs, so which one will be the router ID?
Dot two. 192.2.
192 dot
One six.
168.1.1. Okay, this is the highest, right?
Oh
So
yeah,
this will
yeah.
become the router ID. Let's talk about this one. We have a single IP address. This will become the router ID. For this one, this will become the router ID, and for this one, this will become the router ID. Clear? Because there are single interfaces. If there are single interfaces, so there will be no election processor. Single IP will become the router ID over here. Okay. So this is all about the router ID election. Okay. Now let's discuss about how the OSPF protocol works. Okay. With taking an example. Clear. Now let us consider the two routers. First of all, we will consider the OSPF process in between the two routers. Later on, we will create a big network on which we will consider the areas also. But if there, let's start with two router. Let me turn on these two. Okay, connect them via cable, just like this. Okay, with a fast Ethernet cable. Clear? Okay. So these two routers, when configured with the OSPF, when configured with the OSPF, the neighborship will be done, right? They will exchange the databases also. Okay. But here this process is basically a 7 step of process. What? 7 steps of process. Okay. To create a full neighborship in between two routers. And this is also called 7 states of OSPF. What? 7 states of OSPF. Clear?
Yeah.
So first of all, let me mention a network in between them. Let us assume network is 10.0.1.0. Okay, this is the network in between them. So for the router one, the IP address will be 10.0.1.1. Okay, for this router, let us assume the interface IP is 10.1.10.0.1.2. Clear? Okay. Now, first of all, provide the IP address to the routers, and then we are going to discuss about the 7 state process of the OSPF. Okay, here we have router 1 and router 2. Okay, so let me right click over here and click on Start Capture. Dear, this is the Wireshark tool on which we will capture the packets in between these two routers. Okay. So let's start with R1 then R2. Okay. So configuring terminal. Okay. Interface F0/0 no shut. Okay. IP address is 10.0.1.1 and 255.255.255.0. Okay, whenever I will provide the IP address, okay, well, this is not showing, but sometimes you will see an additional packet also. that will mention the gracious arc. What? Gracious arc. In gracious arc, the source and destination will be the same as source. This is just a dummy packet forwarded to forward the update to others. Okay. This is a CDP protocol that is working. A loop is working. Do you know what is the function of these?
And to discover the neighbor.
Yeah, to discover the neighbor. That's it. So this will discover the neighbor. Okay. In neighbor discovery, it will find the MAC address. Okay. IP address and the device identity. What is the device identity, like which series of router you are using? Router 3, 3, which one is this? 3700 series, right? 3725. Clear? So these details will be forwarded in the CDP protocol basically. Okay, this is also called Cisco Discovery Protocol, and loop is just forwarded to check that the neighbor is working or is connected or not. Okay. So secondly, let's go to router number two. Provide the IP address configuring terminal. Okay. Interface F0/0, no shutdown. IP address is 192.168. Oh, sorry, 10.0.1.2 and 255.255.255.0. You can ask me, sir, you are provide some sometimes that it is basically a belong to class A and subnet mask belong to class C.
Yeah.
How is it possible? So we have done the subnetting over here. Okay,
Yes.
clear? Because
Clear.
this protocol support the subnetting. That's why we have done the subnetting over here. Okay, so that is why the class is different and subnet mask is different, because these become the classless. After doing the subnetting, you already know that after doing the subnetting, the IP address become classless. Okay, that is why it's different subnet mask. Clear? I think you already know about the basics of subnetting. Now, dear, currently there is no packet flow of the OSPF in between them. Clear? No OSPF
Yes.
packet flow. No OSPF packet forwarding, right? Packet forwarding. So this is the first state of the OSPF. This is called down state. Which one? In down state, no packet forwarding, no routes forwarding, no packet forwarding. Okay, let me mention here. Okay, which one is the state number one, dear all? State
Downstairs.
state number one. This one is down state. Which one? Down state. Okay, in which no no OS OSPF packet forwarding. Clear? Forwarding. Okay. Once I advertise the network on router, I didn't have advertised this network. Clear, everyone? Let me advertise the network and start the OSPF process and advertising this network. The router will start forwarding what? A hello packet. Why the router will forward the hello packet? So there are two reasons to forward the hello packet. First reason is,
To form adjacency.
yeah, to find the OSPF neighbor, okay, using multicast, right or not? No,
Yeah.
if the neighborship will be done, why the hello packets will be forwarded?
To maintain.
Yeah, to maintain the neighborship, okay, to maintain neighborship, okay, clear? So for now, the hello packet will be, once I will advertise the network in one first router, the hello packet will be forwarded just to find the neighbor. Clear? Let me advertise the network over here. Okay. Router OSPF process ID is 1. Okay. Network, this is 10.0.1.0, and we will provide the wildcard mask dot 255.0.0.0.255 area 0. Clear? Router OSPF1 network. Now you can ask me, sir, what is the meaning of this 0.0.0.255? It's not looking like the subnet mask, right or not?
Yeah.
What is this?
What?
The wicked.
This is called wild card mask. Okay. All of you know how to calculate this?
Yeah.
Others? Hello. Other
Yes,
student, you know how to calculate this?
yes,
Okay. That's perfect. Okay, dear. So this is just an, you can say this is an inverse of subnet mask. If anyone want to calculate this like class, for a class A IP addresses, the subnet mask is 255.0.0.0. Okay, if you want to calculate the wildcard mask, just subtract this subnet mask with the global broadcast, that is called 255.255.255.255. It will become the first octet will be subtracted from the first octet, it will become 0. Then second octet 255 minus 0, it will become 255.255.255. Clear? But here we have the subnet mask, that is 255.255.255. When you will subtract this to the 255.255.255.255, it will answer you this one. Okay. Now let's move further. When I just advertise this network 10.0.1.0, you will find that a packet will start forward, and this packet is a hello packet, right? In this hello packet, the source is our source IP address, 10 router 1 IP address 10.0.1.1. On destination, it is having a multicast IP address of 224.0.0.5. This is the multicast IP, right or not? Is used to find the neighbor. Okay. Now, now let me configure. Yes, yes. Okay. Router 1 is forwarding a hello packet, right? So this is called the init state. This is called the init state in which the router start forwarding a hello packet. This is the second state of the OSPF in which router start forwarding a hello packet or multicasting the hello packet, right or not?
right.
Clear?
Yeah.
In
Yes,
state 2, the router, this is called init state. What? Init state. In this state, router start forwarding a hello packet, right? Basically, we can say it start multicasting the hello packet with the multicast address of 224.0.0.5. Clear? Now,
yeah.
Yeah.
let me add, yeah, let me advertise the network on the second router also. Let's come back to our network again, router 1 and router number 2. Okay. So router OSPF 1 network 10.0.1.0. Okay. 0.0.0.255 area 0. Clear? That's it. So you will find that another router will start forwarding the same packet, but you will see that lots of packets are there. What are these packets? DBD, DB description, LS request, LS update, LS acknowledgement, and so on.